Good morning, students. Today, we are going to discuss about light. Light, as you know, is a form of energy. Light is a form of energy. We have different forms of energy. Light energy, heat energy, sound energy. Light is coming to us from the sun. Whatever light we get during the daytime, we are getting from the sun. So sun is the natural source of light. Sun and the other stars. Only these are natural sources of light. Others all are man-made, or what we can say artificial sources of light. Whatever light we are getting during the daytime, this is the natural source. All others, we are having tube light, series, and this and that. So many sources of light are there. They are all man-made sources of light. All right. This light has some properties, or you can say light has some characteristics. What are the characteristics of light? One is rectilinear propagation of light. Second, reflection. Third, refraction. Fourth, dispersion. Fifth, total internal reflection. Okay. There are some more like interference. All right. Then there is one more that is called diffraction. Let's focus on these properties. Rectilinear propagation of light. What do you mean by rectilinear? Yesterday I told you rectilinear motion. That means what? Motion of an object along a straight line. We call it rectilinear propagation. So here also rectilinear propagation means light always travels in a straight line. It doesn't travel in a zigzag fashion. It always travels straight. Now, sun is there. There is a window here, and sunlight comes only if the window is facing the sun. Otherwise, you get what you get is the diffused light. Light will come into our house, no doubt, but that is called as a diffused light. There is a small experiment to show rectilinear propagation. Suppose you take three cardboards of the same size. And make a hole. Now this is a cardboard. You make a hole at about 3 inches from the base, so that all the three cardboards are in line, right? Keep this on a table. And on one side of the table, keep a candle. If you observe from the other side, you can see this flame, candle flame, from the other side. Now there are three holes, is it not? This is one hole, this is another hole, and this is third hole. All the three holes are in one line, in straight line. That is why you are able to see the candle flame from the other side of the cardboard. Now, if you suppose displace this cardboard to this side, you slightly move it towards one side of the table, you will not be able to see the sunlight, or this candle flame. Again, if you bring that candle, that cardboard in line with the other two cardboards, if you keep them again in its original position, that means if all the three holes again come in one line, then you will be able to see this candle flame. So light doesn't travel like this; it travels always straight. This is called rectilinear propagation of light. Now you might have seen in the cinema halls, there will be a projector on the back side and screen in the front side. You see the light beam coming straight to the camera, this screen. Is it not? Like also, if there are ventilators and if the sun comes to the middle of the sky, light from the sun enters through these ventilators as beams of light. Straight, you can see like a cylinder. It looks like a cylinder. Is it not? A beam of light enters your house from the sun. That is what is called as rectilinear propagation of light. Now, reflection. This is another property. What do you mean by reflection? Whenever light falls on a smooth polished surface or a hard polished surface, the light comes back. You can say bouncing back of light from a smooth polished surface is called reflection. Now there is a silver screen on the other side. If light falls on that, it reflects. Whatever light is falling on us, see, we are all able to see the objects around us because of reflection only, right? Now, the best surface, reflecting surface, as which we are using today, is a mirror. Is a mirror. Right? Now, you might have heard in the olden days, the queens and Rajkumaris used to go to the reservoirs. Kolai, Kola. Even today, we have in our palace, Mysore Palace, or in all the forts of Rajas, Maharajas, there will be a reservoir, right? Kalyan, it's called. They used to go and bath in these reservoirs and see their reflection in those waters. So, water used to act as a reflecting surface. Water used to act as a reflecting surface where they could see their images and makeup. There is another story also. See, there are two stories. One story of lion and the hare or the rabbit. There was a jungle. In the jungle, there is a king, that is the lion. Every day, this lion used to hunt and kill so many animals. So, destruction of animals was taken every day. It did not eat all the animals, but used to kill them, eat only one. So, all the animals had a meeting. So, they decided every day one of us will go as a food to the king so that others will continue remaining existing, or the whole jungle will become devoid of all the animals. Will soon there will be destruction of all the animals. All animals agreed. They went to the king and told their decision. King also said, okay, happy. He was happy. He need not go hunting for after these animals. Food comes to his den. So one day it was the turn of a rabbit. This rabbit thought of a plan. I should somehow save the animals of this jungle. Otherwise, king will kill all the animals. It went on roaming in the jungle, and at one place it saw a well. And in the well there will be water. So it just peeped from the top of the well, saw its image, its reflection. It thought of a plan, purposely went late to the lion. Lion was furious, very angry. You are such a small animal, and that you are coming so late for my lunch. Hare said, no, no, no. While I was coming, another lion blocked my way. It said, I am the king of this forest, not you. So you should become my food. I pleaded, somehow convinced him, and came here. So this fellow got angry. He said, show me that lion. This hare took that lion to the well. Lion peeped, saw its image, got angry, roared, so I will kill you, jumped from the well, and was killed. The gist of this story is reflecting surface, water acting as a reflecting surface. We can see now also. See, there are two types of waters. One is still waters, and second, flowing waters. What do you mean by still waters? Waters where there is no flow, like the well or a pond. Is it not? Flowing water means where there is continuous flow, like the river or a stream. Jaranantati. Is it not? Where the water is flowing, it will be continuous, like wave-like motion. Is it not? Here in a well or a pond, it will be steady, still waters. Whatever reflection you see here of your own body, okay, here you get a clear image. Here you get a blurred image or distorted image. In case of still waters, you get a clear image. You can see your reflection, clear reflection. Whereas in a flowing water, your image appears to be blurred, not clear at all. Part by part, distorted image you get. Is it not? So the image that you get in a still water or standing water, we call as a regular reflection. We call it as a regular reflection. And the image that we get in flowing water is called as a irregular reflection. Means what? This is the reflecting surface. This is another reflecting surface. Whatever light rays fall on this, it gets reflected back, means bounce back. Now another light ray falls on this. So this we call, or whatever light rays get reflected from the reflecting surface, they form a beam of light. See, they form a beam of light. See, all are parallel. See, all the reflected rays are parallel. This is what we call regular reflection. We call it as regular reflection. But in this case, see, one light ray goes like this, another may come like this, the one which feels here may go like this. So after reflection, all these light rays move in different directions. This we call as irregular reflection. This is called as irregular reflection. This happens because light rays get scattered in different directions. They get scattered in different directions. The best reflecting surface that we know is a mirror today. Earlier, even metal plates, especially copper, metal plates were used as reflecting surfaces by the kings, queens. Right after the water, when the metal was discovered, they started using copper, that too copper. Copper is a very good reflecting surface if it's polished. You know, all metals are shiny. If it is polished a little bit, this acts as a best mirror. Then this mirror, glass mirror was discovered. They invented the mirror. What is mirror? This is again one side. This is a transparent glass. On one side of this transparent glass, some compound of silver is coated, so that it acts as a reflecting surface. Silver chloride, silver bromide, something like that, right? Okay. Now, reflection takes place from two types of mirrors. Mirrors are of two types. One is a plane mirror, and another one we call a spherical mirror, or we also call it as a curved mirror. Now, in a plane mirror, the surface is smooth, uniform, even. Is it done? If a light ray falls on this mirror, it gets bounced back, or you can say gets reflected. The light ray which falls on the mirror is called as the incident ray. You can say light is incident on the mirror. Light is incident on the mirror. The light ray which falls on the mirror is called incident ray. And the light ray which comes out of the mirror is called reflected ray. Both these rays meet at a point, and if you draw a perpendicular to this point, this we call as normal at the point of incidence. This is called normal at the point of incidence. This is the incident ray, this is the reflected ray, and this is the normal at the point of incidence. Now, all of them are lying in the same plane. This is the reflecting surface. And when light ray falls on this surface, it gets bounced back, it gets reflected back. Is it not? So, all are in the same plane. Secondly, if you measure the angle between the incident ray and the normal, and angle between the reflected ray and the normal, they will be found to be same. This is what we call angle of incidence, angle of reflection. So, angle of incidence is equal to angle of reflection. This is the first law of reflection. Laws of reflection. First law is angle of incidence is equal to angle of reflection. And second law, incident ray, reflected ray, and normal at the point of incidence all lie in the same plane. These are the two laws of reflection. One is angle of incidence is equal to the angle of reflection. Second, the incident ray, the reflected ray, and the normal at the point of incidence all lie in the same plane. These are what we call laws of reflection. These laws of reflections are obeyed by both the mirrors, the plane mirror as well as the spherical mirrors. It applies to both, right? Now, where do we use these plane mirrors? Plane mirrors are used firstly as makeup mirrors. Every day we stand in front of the mirror and see our image. Is it not? Huh? We get ready when we go out, we get ready when we are going for a function. It's our habit to see the mirror as much as possible, right? Especially the teenagers, youngsters. They are very conscious about their figure. Look, secondly, these are used in what we call as kaleidoscopes. Thirdly, they are used in periscopes. Means what? Kaleidoscope is looking something like this. See, there are three pieces of plane mirror, if I can say. Okay, three longitudinal pieces of mirrors which are arranged at an angle of 60 degrees each. So when you arrange these plane mirrors like this, it looks like this. Okay, on both the sides, triangle. Okay, angle between these two lateral surfaces is 60 degrees, and on one side it is covered. One side it is covered, and on the other, so there is also a mirror at the base. Also, there is a mirror, triangular mirror, and on this side there is a small hole. This is called as a kaleidoscope, and in the kaleidoscope you can use plastic beads or bangle pieces. Different colored bangles will be there, glass bangles. The bangle pieces can be kept in the kaleidoscope. It is, if you keep on rotating it through this hole, you can see different arrangements, designs. There is a very big kaleidoscope in our museum here in Bangalore, right? Now, periscope. Periscope is an instrument which is used in ships, submarines, especially the submarines, to see the image of enemy ships on the surface of water. Now, recently, you have seen Ramlala, Ayodhya temple. On this, is it not? Huh? There was an arrangement to see that sun rays directly fall on the forehead of Sri Rama, Ramlala. Is it not? ಅವತ್ತೇನಂತ ಹೇಳ್ತಿದ್ದಕ್ಕೆ ಎಂತ ಅಭಿಷೇಕ ಅಂತ ಹೇಳಿದ್ರದಕ್ಕೆ ಸೂರ್ಯಕಿರಣ ಏನೊಂದು ಹೆಸರಿತ್ತಲ್ಲ ಅದಕ್ಕೆ ಐ ಫಾರ್ಗಾಟ್ ದಟ್ ನೇಮ್. Sun rays should directly fall on the forehead here, tilaka, surya tilaka. Is it not? Was done. What it is actually? It is a combination of mirrors and lenses only. It is a combination of mirrors and lenses, so that the light rays of the sun get directed through pipes and fall on the forehead. That's all. Same thing is done here in a periscope. there are two mirrors. Now they are using prisms. Okay. This is one mirror. This is another mirror. So if there is an enemy ship here, right, which is sailing on the seas or oceans, the reflection of this ship, this is a mirror, is it not? Which is placed at an angle of 45 degrees. This is also at an angle of 45 degrees. The image of this ship will fall on another mirror here. So these two mirrors are parallel to each other. They are parallel to each other. The reflection of this is seen by a person who is sitting in the submarine. And this can rotate at 360 degrees. You might have seen all war movies, many war movies, especially English movies. Is it not? They will see the enemy ship from here and they will fire the missiles, especially Pearl Harbor and such movies. War between America and China, Japan and America, right? Pearl Harbor. Such movies they show this one, right? Some they are sitting in a submarine, then they will see the enemy ships and fire missiles, bombs, right? This is what we call as a periscope, right? Now, what is the nature of images that we see in a plane mirror? What is the type of images? What is the nature of images that we see in a plane mirror? Image formation in a plane mirror. Firstly, when we stand in front of the mirror, the size of image will be equal to the size of the object. When I stand in front of the mirror, my image will be of the same size, neither small nor big. Image size is equal to object size, same size of the image. Secondly, when I stand in front of the mirror, my image will be formed at the same distance as the distance between mirror and myself. Means object distance is equal to image distance. Object distance is equal to image distance. Means what? If I move forward, the image will also come forward. If I move backward, image will also move backward. That's why object distance is equal to image distance. And thirdly, when I comb my hair, my right hand appears to be the left and left hand appears to be the right. Similar means all the right side of my body appears to be the left and vice versa. This is what we call as lateral inversion. This is called lateral inversion. My body appears to be laterally inverted. Right side appears to be left, left side appears to be right. And fourthly, where do you see the image? You see the image behind the mirror. Can you get the image on a screen? No. So the image which appears behind the screen, which cannot be captured on a screen, is called as a virtual image. We call it as a virtual image. So the image form is a virtual image. It is a laterally inverted image, and the distance between mirror and object is equal to the distance between mirror and the image. The size of image is equal to the object size. These are the natures or the characteristic of image that is formed in a plane mirror, right? Now coming to the spherical mirrors. ಸ್ಪೂನ್ ಇದೆ, ಸ್ವಲ್ಪ ಶೈನಿಂಗ್ ಇದೆ, ತಗೊಂಬ ನೋಡೋಣ ಯಾವ ಸ್ಪೂನ್ ಇದೆ. Spherical mirrors of two types: concave mirror and convex mirror. Now, simple example. So this is a sphere. Say, for example, a ball, right? This is a spherical object. Now, if you cut a small piece of this ball, it will also appear round. Is it not? If you cut a small portion of the ball from the side, and if you turn it, it will also appear round. Is it not? This is the cut portion of a ball. This depressed part or depressed surface we call as a concave surface, and this bulged surface is called as a convex surface. Now see, this is a spoon, right? This part, the depressed from which we take the food or whatever we eat for eating, teaspoon we call, right? This part is called a concave surface, and this part we call as a convex surface. This is depressed one, this is bulged one. If you see, this is old spoon. If you see in a new spoon, the shiny surface, which is having a shiny surface, if you see your face in on this side of the spoon, your face appears to be stretched, dragged. If you see your face on this surface, your face appears small, diminished, right? The center of the depressed part, whether it is this side or this side, this is a concave, this is a convex surface. The center of the spherical part, whether it is concave or convex or this one, is called as pole. It's called pole of the mirror. Say, for example, here, this part, right? This is a part of the sphere. The center of this part we call as pole, and center of the sphere, this one, is called as center of curvature. This is called center of curvature. Center of the whole sphere is called center of curvature, and center of the spherical mirror or spherical surface, which is a part of the sphere, is called pole. And the line which joins these 2 points, that is center of curvature and the pole, this line is called as principal axis. The line which passes through center of curvature and pole, center of curvature is denoted by the letter C, and pole is denoted by the letter P. The line which passes through the center of curvature and the pole of the mirror is called principal axis. right? Whether it is a concave mirror or a convex mirror. First, let us take the concave mirror. How are images formed in a concave mirror? The nature of image formed in a concave mirror depends upon its position. This is the principal axis. This is your pole, and let this be center of curvature, right? Means what? If you extend this, this will become the center of the whole sphere. Now, if you keep an object here at infinity, quite far from the mirror, what will happen? Light rays fall, travel parallel to the principal axis, get reflected. Another light ray passes parallel to the principal axis, again passes through. Similarly, light rays coming from here, all the light rays, after reflection, they pass through a common point. This common point is called principal focus. The point where all the light rays meet after reflection, we call as principal focus. And the distance between principal focus and pole, the distance between principal focus and pole is called as focal length. It is called focal length of the mirror. This is center of curvature. This is principal focus. And the distance from center of curvature to pole is also called radius of curvature. It is called radius of curvature. Distance between center of curvature to pole is called radius of curvature, represented by the word R. And this radius of this one, this is R. You see, this R is double the focal length. Focal length is shown as small f. Principal focus is shown as capital F. Remember this, okay? Focus is shown by the letter capital F. Focal length is denoted by small f. Now this R is equals to 2f. R is equals to 2f means what? The length of this from center of curvature to pole is double the length of this focal length. Or you can say f is equals to r by 2. So if radius of curvature is given, you have to find the focal length of that mirror divided by 2. Say for example, radius of curvature is 30 centimeters. Then what will be its focal length? 30 by 2. This is r. So this will become f, that is 15 centimeters will be the focal length. All right. Now, Right? See here, all the light rays are meeting at the one point. Here, on the other side, this is a convex mirror. In a convex mirror, the light rays are traveling parallel to the principal focus. They are traveling parallel to the principal focus and getting reflected. See? These are incident rays and these are reflected rays. So in case of a concave mirror, these light rays meet at a point after reflection. Now in case of a convex mirror, all these light rays travel parallel to the principal axis, get reflected, and when you extend all these reflected rays, they meet at a point behind the mirror, and that forms the principal focus. Here, this forms the principal focus. That's the difference. In case of a concave mirror, principal focus is formed in front of the mirror, whereas in case of a convex mirror, principal focus is formed behind the mirror. When you extend all the rays, they meet at a point. Means what? This is called as a converging mirror. That's why this is called as a converging mirror, where all the light rays converge. Converge means meet at a point. Whereas here, light rays appear to be coming from a point behind the mirror. That's why this is called a diverging mirror. Concave mirror is called as converging mirror, and convex mirror is called a diverging mirror. All right. This is what I told you, angle of incidence, angle of reflection and all that. Now see here. This is a concave mirror, hard surface. This is focal length. Distance between principal focus and pole is called as the focal length. And the center of the whole sphere is called center of curvature, which is 2f. The same thing I told you. Okay. Now here, in case of a convex mirror, always in both the mirror, whether it is a concave or a convex mirror, light always falls from the left side. Means what? Light is incident from the left side of the mirror. So here also, see here, light rays come here, fall on this surface, get reflected. They all meet at a point behind the mirror. Now, at different positions, you have different types of images. When the object is at infinity, you get a point size image, at the principal focus, which is real, inverted, highly diminished, very, very small, very tiny image is formed at the principal focus. Now, if you keep the object beyond C, beyond center of curvature, then you get a real, inverted, diminished image between center of curvature and principal focus. When an object is placed beyond C, beyond the center of curvature, see, center of curvature is here, object is placed here, then you get a small image, real, inverted, at a point between center of curvature and principal focus. If you keep the object at the center of curvature, then you get an image exactly below the object, which is the same size as the object. See here, object is placed at center of curvature. You find the image just below the object, and the size of image is equal to the size of the object. So here a real inverted image of the same size as object is placed at center of curvature. Now, if you move the object again forward, means in between center of curvature and principal focus, you get a enlarged image. Now see here, object is small. You have placed the object between center of curvature and principal focus. If you keep the object between center of curvature and principal focus, you get an enlarged real inverted image beyond the center of curvature. The object is small, image is large. Here, object is and image both are same. Here, object is large, image is small. So, formation of images in a concave mirror uh, depends upon the position of the object from the mirror. Now here, you see, when the object is placed at the principal focus, all the light rays after reflection travel almost parallel to each other and meet at a point somewhere at infinity. Somewhere at infinity. And the image form may be real inverted. Now, as you move forward, if you keep the object between principal focus and the pole of the mirror, ಇಲ್ಲ ಇಲ್ಲಿ ನೋಡಿ ಇಲ್ಲಿ 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 ಏನಾಗೈತೆ ಏನಾಗೈತೆ ಇಟ್ಸ್ ಆಲ್ ರೈಟ್ ಅಲ್ಲಿಗೆ ಹೋಯ್ತು ಅದು ಇಲ್ಲಿ ಓಕೆ ಓಕೆ ರೈಟ್ in the last case where the object is placed between principal focus and pole, you get a very enlarged virtual erect image behind the mirror. When the object is placed between principal focus and pole of the mirror, you get a virtual erect enlarged image behind the mirror. This is made at use of by the dentists. This is made use by the dentist. They keep our tooth at a point between focus and the pole so that they get a enlarged image of our teeth and they can see the defects in our teeth. All right. This is one use of concave mirrors. Concave mirrors are used by the dentist to see the deformities or cavities or whatever problem is there with our teeth. All right. All right. Now, what are the uses of these concave mirrors? I have seen this, is it not? Different positions of images, different nature of images. In all the cases, we have real inverted, except for this position. When the object is placed between focus and pole of the concave mirror, you get a virtual image, a large image. Except for this, we have concave, in concave inverted images. All right. Now, uses of concave mirrors. Where do we use concave mirrors? First and foremost, in the headlight of vehicles. In the headlights of vehicles, so that we get a parallel beam of light. In our cars and all, we have low beam and high beam. Even in all the vehicles, we have that, is it not? What happens? Or you take a simple torch. The bulb is here. Whatever light rays fall on the reflector, there's a metal reflector inside, is it not? Whatever light rays fall on the reflector, all the light rays form a beam. So all the reflectors of our vehicles, all the lights will be having a concave mirror. Secondly, they are used in solar furnaces. They are used in solar furnaces. They are used in searchlights. Whenever there is a circus or any exhibition, beams of light are kept on the sky. They'll be rotating. Is it not? Beams of light, huge lights will be there to show that there is some exhibition or something, some special event taking place in that ground. So in those such lights, you will have these concave mirrors. All right. Now a convex mirror always forms virtual, erect, diminished image. A convex mirror always forms virtual, diminished, and erect image. Whatever be the position of the object, whenever you keep the object, you will always get a virtual, erect, and diminished image. So this property is used in rear view mirrors. All our vehicles have side mirrors, is it not? They are called rear view mirrors. In a rear view mirror, you get a small image, diminished image of the vehicles coming from back side. Is it not? That's why it's called a rear view mirror. And also in all the complexes and even in the apartments, there will be a huge convex mirror at the junction. Suppose there is a road here and there is a road here also. They keep a convex mirror here at this point, so that a person coming from this side can see vehicles from the other side. A person coming from this side can see the images of vehicles from the other side. And at blind corners, you will find convex mirrors. Whether it is a what you call mall or whether it is apartment, also in public roads, you can see some convex mirror, large convex mirrors at the junction of two roads where there is a blind corner. So this is another. This is the main use of our convex mirror. Another thing, if you have seen, the letter ambulance is written as an image. The word ambulance is written in a different way. ECNALUBMA means what? When people who see the image of this word in their mirrors, they will identify it's an ambulance. We should give way. Is it not? To bring that awareness or instinct in the people, this is printed ulta. The image, mirror image of ambulance is written on the ambulances. That is the main use of your convex mirrors. All right. There is one formula which is called as mirror formula for both concave and convex. It is 1 by F is equals to 1 by V plus 1 by U. This is called as a mirror formula, where F is focal length, U is V is image distance, and U is object distance. Right? F is focal length, V is the image distance, and U is the object distance. And remember, For convex mirrors or convex lenses, always f is positive. And for all concave mirrors or lenses, the value of f is negative. This you have to see. Right? They may not ask, but in case it is asked, the focal length of convex mirrors or lenses is always positive, and the focal length for a concave mirror or a lens is always negative. Right? And secondly, magnification. What do you mean by magnification? What is the size of the image? Is it bigger than the object? Is it smaller than the object? For that also we have an formula, that is HI by HO, means height of the image by height of the object is equal to minus V by U. That is image distance by object distance. Magnification is equals to height of the image by height of the object, or it is also equal to the image distance by object distance. This is about the reflection, both in plane mirrors as well as spherical mirrors. Another property of light is refraction. What is refraction? Bending of a light ray when it travels from one medium to another, we call as refraction. Another property of light. Now, for example, we are standing on the bank of a swimming pool. This is the incident ray, and this is called as the refracted ray. This is angle of incidence, this is angle of refraction. Now this is air. Say a light ray travels from air to water. Now you are standing on the bank of a swimming pool. If you are standing on the bank of a swimming pool, for you, the floor of the swimming pool appears to be raised. The floor of the swimming pool appears to be raised. Or if you are standing on the top of a well, if you see below, the floor of the well, if it is not a very deep well, the floor means mud and all will appear to be raised. And you will say it's very shallow water, I can go have a dip. When you get down into the water, same thing happens in rivers also, right? But when you get down into the well or the river, your feet will not touch the base because water will be very deep. But for you, it appears to be raised. This is what we call refraction. So when a light ray travels from one medium to another medium, it undergoes bending. It undergoes bending. This bending of light ray is called refraction. Another simple example I'll give you. Take a glass bowl, fill it half with water, and in that bowl keep a coin. Keep a coin, 1 rupee coin or 2 rupee coin, and observe it from the side. If you observe it from here, the coin appears to be raised. the coin appears to be raised. Actually, it is at the base of the ball. But if you observe it from the top, the coin appears to be raised. This is because of deviation from its original path. This we call as refraction. Another simple example. Take a glass of water, fill it with water, not full, half, and then keep a pencil. If you keep a pencil in a glass of water, it appears to be broken. It appears to be broken. The upper part appears separate and lower part appears separate. This is again bending of light ray. This is also example of refraction, right? Very simple examples. When a light ray travels, this air is called a rarer medium. Means the particles are away from each other. This is called a denser medium, where the particles are very close to each other. They are closely arranged. Density of the medium. Here the particles are closely arranged. Here the particles are away from each other. So this we call as a rarer medium. And this is called as a denser medium. You can also take another example, glass. So when a light ray travels from rarer medium to denser medium, it bends towards the normal. This is the normal, the perpendicular drawn at the interface of two transparent media. These are two transparent media. Air is transparent media and water is also a transparent medium, right? So at the interface of two transparent medium, we have drawn a perpendicular, which is called normal. When a light ray travels from a rarer medium to denser medium, it bends towards the normal. The opposite. When it travels from denser medium to rarer medium, it bends away from the normal. Right? You can see refraction through various transparent objects. We have prisms, we have rectangular slabs, we have lenses. Different objects are there. This is a rectangular glass slab. Rectangular glass slab. Take a piece of paper, white paper, keep a rectangular slab like this. Fix two pins, normal pins, P and Q. Draw a line at an angle. Fix two pins P and Q. Observe the image of these two pins from the opposite side of this glass slab. And looking to the images of these two pins from the opposite side of the glass slab, fix two more pins R and S. Fix two more pins R and S. You will see that all the four pins P, Q, R and S all will be in the same line. All will be in the same line. Mark the outline of this glass slab. Join these two pins, which forms a light ray. Join these two pins, it will also form a light ray. Remove the glass slab. You can mark the edges as A, B, C, D. Remove the glass slab. Join, see, draw a perpendicular passing through this light ray at this AB surface. Draw another perpendicular so that it passes through a point at this CD, on the face CD. Remove this and join the 2 points where the normal is intersecting the incident ray and the other ray which is coming out of the glass slab, which we call as the emergent ray. This is one normal, this is another normal. Say this normal is MN and the other normal is M1 and 1. What do you see here? The light ray which is passing through the air enters the glass. As it enters the glass, see, this is a rarer medium, this is a denser medium. So naturally, when light ray travels from a rarer medium to denser medium, see, air is there, glass is there. Again, air is there. So when light ray travels from air to glass, because it is traveling from a rarer medium to denser medium, it bends towards the normal. See? Now again, it is traveling from denser medium to rarer medium, that is from glass to air. It bends away from the normal. See here, see this angle, and see this angle. This is angle of incidence. This is angle of emergence, theta. Theta is angle of emergence. And this is angle of refraction. Three angles we have. This is the angle of incidence, this is the angle of refraction, and this is the angle of emergence. All right? Now, if you extend the incident ray, you will find it laterally shifted. It will be parallel to the emergent ray. This ray is laterally shifted towards the other side. So the emergent ray and the incident ray will be parallel to each other. Why it happens? Why is the emergent ray found to be parallel to the incident ray? Because of one reason. There are two interfaces, air glass, glass air. So the extent of bending at the two interfaces, that is AB and CD, is same at the two opposite faces. The extent of bending of light ray at the two opposite interfaces, that is AB and CD, is same. That is why you find this emergent ray parallel to the incident ray. All right. Now, lenses. What is a lens? Lens is a transparent glass object. Lens is a transparent glass device which has at least one side curved. We have different type of lenses. One side is plane, another side is curved. So we call it as plano convex. Here, one side is plane, another side is curved. So plano concave. Here, both sides are depressed. That is, we call it as biconcave or simply concave. Here, both sides are bulged, means curved outside. We call it as convex or biconvex. And here we have concave as well as convex. So it will be concavo-convex. But the most common lenses that we use are these two. concave one and a convex one. Concave and the convex one. Lenses are formed because of two spheres. Lenses are formed because of two spheres. When two spheres overlap each other, then you find a convex lens formed. When two spheres come close to each other, then you find a concave lens. So these are the two ones. See, this is a concave lens, this is a convex lens. Okay. The center of both the spheres we call as center of curvature, C1, C2. A mirror has only one center of curvature, whereas a lens has two center of curvatures, 1 and 2. And of course, there are two principal focuses. Now, the line passing through both the centers of curvature we call as principal axis. This is called as the principal axis. It joins both the centers of curvature. The center of the lens is called as optic center. Center of the lens is called as optic center, whether it is a convex lens or a concave lens. The center of this is called as a optic center. This is optic center, this is optic center. And a lens has, this is your center of curvature. There are two principal focus on one side, focus on the back side. Lens has two centers of curvature and also two principal focus or foci, what we call. Right? And always in a convex lens, we have real inverted images. Whereas in a concave lens, we have virtual erect images. See here, this is a convex lens. All the light rays are traveling parallel to the principal focus, and after traveling parallel to the principal focus, they bend and they all meet at a point which is the principal focus. It is the principal focus. But the image is formed on the other side of the lens. Always light is incident on the left hand side and image is formed on the right hand side. Okay, in all the cases you find real image, real inverted, except for one position in convex lens, that's again between F and O. Means when the object is placed between the principal focus and the optic center. This is the optic center. When the object is placed between the principal focus and optic center, then only you get a virtual erect image on the same side. Otherwise, you always get a real inverted image. But in case of a concave lens, you always get a virtual erect image, and that too diminished. That too diminished. All right? And convex lenses are called as converging lenses. And concave lenses are called diverging lenses. Now see here, all the rays after refraction, they are meeting at one point. This is convergence. Is it not? All the light rays after refraction, they are meeting at one point. That's why it's called a converging mirror, a converging lens. The distance between optic center and the principal focus we call as focal length. Same, right? Distance between the optic center. All measurements here in case of lenses are made from optic center, whereas in case of mirrors, all measurements are done from the principal focus. All right? And this is what we call principal focus. Here also the same thing. R is equals to 2F. Same thing. Same rule applies here also. See here, when the light gets refracted, all these in case of a in case of a concave lens, see all the rays are incident from the left hand side. They get refracted, and when you extend these refracted rays, they meet at a point on the same side of the lens. They meet at a point on the same side of the lens, which is called as, again, the principal focus. Right? Now, all these light rays appear to be coming from this point. That's why concave lens is called a diverging lens. Here it is called converging lens. It is called a converging lens. Now, there is a lens formula. There is a lens formula for calculating the image distance, object distance, or you can calculate the focal length. It is 1 by f is equals to 1 by v minus 1 by u. In case of mirrors, it was plus. Here it is minus. And magnification. M is equals to height of image by height of object is equals to v by u. Magnification, to see whether the image is smaller or larger than the object, that is called magnification. Height of image by height of object is equals to image distance upon object distance. This is magnification, and this is your lens formula. Okay. Okay. There is another topic to be discussed that I'll discuss later. That is refraction through a prism. Refraction through a prism. Prism is a transparent glass device which has two triangular bases. A prism has two triangular bases and three rectangular lateral surfaces. And three lateral surfaces. How are the lateral surfaces? They are rectangular. Same way, which I showed you like this. Same thing. If you keep it like this becomes a prism. This is a prism only. Same thing. It is having same. See, two triangular bases are there. One on this side and another on this side. Two triangular bases are there and three lateral surfaces. 1, 2, and 3. 1, 2, and 3. That is a prism. If you keep it like this becomes a prism. So allow light ray to fall on one side. You will get light getting refracted from the other side. The angle between two lateral surfaces. Angle between two lateral surfaces. Now there are, see, 1, 2, and 3. The angle between two lateral surfaces we call as angle of the prism. Angle between two lateral surfaces is called angle of the prism. It looks like this. All right, this is what we call as a prism. Okay, I'll discuss about this tomorrow. This is what we call as angle of A is the angle of prism. There is a simple experiment. I'll explain it tomorrow and come back to you more about this refraction and then about the human eye, which is also a convex lens. The lens which we have in our eyes is nothing but a convex lens. So there also, see here, see, this is the lens what we have in our eyes. So what is a human eye made up of? What are the defects of the human eye? See, this is a crystalline lens that we have in our eyes. So here also refraction takes place. So we'll discuss about refraction through a prism and refraction through our human lens. What are the defects of the eye? All these defects tomorrow. Okay. ಯಾವ್ದು ಖಾಲಿ ಇದೆ? 9 ಖಾಲಿ ಇದೆ. ಓಕೆ, ಆಲ್ ರೈಟ್, ಥ್ಯಾಂಕ್ ಯು. ಹಾಂ, ಅದೇ, ಇಫ್ ಯು ಹ್ಯಾವ್ ಎನಿ ಡೌಟ್ಸ್ ಯು ಕ್ಯಾನ್ ಆಸ್ಕ್. ಏನಿಲ್ಲ.